Um, and it looks like we have a number of people. If I could beg your indulgence and start in about 2 minutes, I'd really appreciate it. I want to get as many people in attending. We have a pretty good sized group here. I'd like to get a little bit of housekeeping out of the way. Because of audio overlay when people want to interject and ask questions, we've actually turned off the ability for us to hear you. What we ask is that you, if you look at your control panel on the right, if you expand it, you have the ability to enter in text questions and raise your hand. I have on the line with me as co-presenters Ted Sturm and Ruella. Ruella, I won't try your last name. And they'll be looking at these questions, and please write questions within an individual screen, or you can save them till the end, either way that you feel comfortable. But Ted will interrupt me and present your question or questions, and I will try my best to answer them as we're going along. And the other thing is, at the very end of the presentation, when you exit out, there's a very brief questionnaire. I'd really appreciate it if you could just take a couple of seconds to fill it out. If they're asking for scores of, 0 to 10 or 0 to 100, just so we can set a baseline, we'll use the academic scale that we're all familiar with. 70 is an average, 80 is a B, 90 is an A. And really, you guys just, all you have to do is put a 99 in there, and I'll look really good. The subject that we're going to cover today is how and where to use NAS and iSCSI in the surveillance market. What we're specifically referring to is NAS as a storage product. NAS stands for Network Attached Storage. And iSCSI is a protocol that refers to Internet Protocol, or IP SANs. And how do you use these? There's different ways that both can be used to maximize your return on your investment, as well as to enhance performance. All right, iSCSI uses a transport that's exactly like disk drives. It moves data in a block fashion. It's strictly ones and zeros. The iSCSI Internet SCSI uses SCSI commands, which is a command structure that has been around for a long time. It started with SCSI attached drives, and is also used in fiber channel implementations. And along the way, there was a perceived need to create a SCSI product that's less expensive to implement than a traditional fiber channel SAN. So the term IP SAN was created. It's less cumbersome, it's faster, and it uses standard components. But as you can see, and I'm showing a very simple relationship between servers transmitting data. When you use iSCSI, that is the typical relationship. It's from a server, or for the security people, an NVR, being able to talk to a centrally held product in the network. iSCSI prefers to, it's best placed on its own SAN or its own network with its own switches, so that it's maximized and not encumbered with collisions and so forth and other things that would happen in the general LAN. So essentially you have a command that says write, and here's the data, read, here's the data. It's very simple, it's very clean, it's very fast. Right. File mode generally refers to network access from a larger population of people, where you have shared requirements. In a general IT or your small office environment, You'll have a server, and you'll have a number of clients or desktops or workstations that need to access common files, such as images, Word documents, spreadsheets, and NAS facilitates the ability for many to share single files. And it's outstanding for its purpose, but it's also a little more complicated in order to achieve these controls. For instance, you have an open Word document and another person opened that same document to make changes. NAS puts in a bunch of control sequences by virtue of protocol and data that enable control and file locking and information such as who made the last change, where were the changes, what was the time, what was the date, what was the source, what was the target for those changes. So as you look at the left-hand side of this screen, you'll notice I have a NAS depiction with, again, a server, and it can be a server, but more appropriately, any number of workstations. And they send their data out, but it's not limited to strictly a Word document or a piece of a video. In the front side, there's that extra information I was talking about, and that's referred to as metadata. So right off the bat, you're transmitting more data than just the core data that you think you're working with, the document, the spreadsheet, and as we move along, I have it tagged in here, the actual video. Now, there are different protocols. In the general file world, Linux likes to use a protocol called NFS, or Network File System. In the Windows world, it's SMB2, and actually in our world that we're going to be talking about, we're going to replace, and you'll see this in a second, we're going to replace those clients and those workstations with cameras. Cameras use a simpler, cleaner protocol called Trivial File Transport Protocol. But again, it's a protocol, it has metadata, and it requires extra layers of software to facilitate the communication of the protocol from the camera or the workstation to its final repository or NAS storage appliance. On the right-hand side of your screen, we show iSCSI and a server. And iSCSI is going to be server-based, and we'll show you where that server resides in the coming screens. But you'll notice it's a lot cleaner. I'm only sending over video. I'm only sending block-level information. And then it's recorded onto an iSCSI storage device, or as we like to call it, an IP-SAN storage appliance. So, NAS on the left, more data is being transmitted. You're also in a network with more components. Instead of a single server or 5 servers or 10 servers talking to a central storage device, now you have 10, 15, 20, 25, 50, 100 different cameras on their camera network sending data. Now you have collisions. You have retries. You're sending more data than just the raw video. You're also processing 2 protocols. One is being generated in the camera. One is processing in the actual NVR to take that data and move it to the right place. So with the burdens of increased traffic and collisions and more data, it's just physically impossible for NAS to achieve the same performance per gigabit link as with IP-SAN. Typically, in a NAS environment, you're depending on the number of cameras, the type of traffic, you can expect 25 to 50 megabytes of true aggregated transfer speed or bandwidth available for that per 1 gigabyte port. All right? Whereas on IP-SAN, by virtue of a cleaner protocol, streamlined data, you get roughly 2 times the available bandwidth for storage and writes as you would over NAS, and that's per 1 gigabit link. Remember, and this is the features available for both NAS storage appliances and IP-SANs. we're going to present up to the IP-SAN side, the back side, if you will, of the NVRs, multiple 1 gig links or multiple 10 gig links, depending on how large the environment is. Okay. A few screens ago, I showed a very simple NAS relationship to a NAS storage appliance. Let's replace that. And now what we're showing is, rather than workstations or servers, we're showing cameras. I'm just depicting this very simply and cleanly, feeding into a PoE switch and feeding that data consequently, in those images are going to be transferred to a Falcon. In this particular case, I'm going to define the Falcon as strictly a NAS storage vehicle, and we're using what we call in the industry smart cameras. Mobotics is a good example, where Mobotics takes complete control of taking the image and writing it to a generic NAS storage appliance. And it met with a lot of success. There are also a number of other people that do that. And they transfer this data using those same protocols, and it's an inexpensive way to record video. Right? However, with these types of smart environments, you're limited. You're going to view live data strictly from the cameras, or you're going to be able to view from a client within the network and view that software. There is no capability to run applications within a Falcon that's designated as strictly a NAS storage product. You get cost savings on an NVR or a Falcon. What we do is we downgrade from a fully blown Windows server product to what's referred to as a storage server product. So there's some savings there. However, those savings are offset by the inherent higher cost of the smart camera. The other thing that isn't available in this strictly NAS, strictly simple NAS type of environment is you're not able to run applications. Generally, it's a featureless viewing and recording environment. Central management is difficult, and it typically lends itself to lower camera counts than you'll find in the next visualization, where you can run more sophisticated applications within the NVR. Just so you know, we call our NVR family the Falcon, and so you can run more sophisticated items. You can run depending on the software that you're using. The analytics can run out of the same box. Or it can be remotely managed. It can be viewed from the same box. If you have a strictly simple NAS, as in the first case, you can't even hook up a monitor to that system. It doesn't support it. So your viewing is going to be strictly across the network with client stations talking to the camera or to the storage. Right, best fit for NAS. Right now, we've defined NAS as an NVR that's taking video feeds from the cameras. On the left side, a great fit. You have a limited number of cameras, typically between 5 and 40 cameras. It's a single site. It's not going to grow beyond a certain amount of terabytes. And now a Falcon or an NVR with limited cameras at one site is a great solution. You can manage it all from that one single NVR, and you can view it. You still have the options of client viewing access, and it's an inexpensive way to go. However, as you'll see later on, if your requirement is you start to add cameras, typically you're going to have to start to add another NVR to handle the camera count. You're going to have its own storage. When you start to move from a single NVR requirement at a specific site, start to consider iSCSI or centralized storage, and we'll demonstrate that a little bit later. On the right side of the screen, I'm showing what is generally referred to as fringe site or fringe recording, where you have multiple locations. All of them have, by virtue of different reasons, have to have their own storage held locally. Again, if that's the restriction or that's the requirement for that site, you can use different size NVRs with different CPU power to handle the number of cameras at each of their locations. You can use different sized NVRs based on how much capacity you need, which is a function or a result of how many cameras, the density, and how long you want to record it. The problem with a fringe site that's depicted here, you can't have any central site requirements. All the storage is held at each site. And if you did need to back up any of the data that's there for legal reasons or after a catastrophic condition and you wanted to review video, it's rather cumbersome. It's expensive to do centralized backup. You have to have larger pipes to move the data from one NVR to a central site. It's just more difficult to do. But there are many situations where you only require storage at the remote sites and limited client viewing across the pipes, across the interconnects. I'm going to take that previous fringe site recording and I'm going to build on it a little bit. On the left side of the screen, what we find is fringe now more and more as we get with the you'll call in and you'll say, this is what I need, and I need 50 terabytes at this site, I need 16 terabytes at this site, I only need 8 terabytes there. We'll come back and we'll say, how big is that interconnect between the different sites? And they say, I've got 1 gig glass, I've got 1 gig dark fiber, I've got X amount of bandwidth I'm paying for several 10 MBS lines. And at that point, we'll look at the net change. We work with our resellers and our reps, and we might come back and suggest, you know what, you have significant bandwidth there. Why don't you reduce your costs and hold less data at all of your fringe sites, and then archive it from all your fringe sites back to a central repository. So what we're allowing you to do is reduce your cost at the fringe sites and centrally hold all of your archived video. Excuse me. So the target generally is a 1 to 2 day buffer at the fringe sites, just in case there's the backhoe that cuts through the glass interconnect. You know, some truck runs over a transformer and power was lost, you know, at a central site. So we recommend a buffering of 1 to 2 days, but doing an actual archive on a daily basis back to a central site. Now, on the right side, I mentioned we were talking single sites with a requirement of, say, you know, 4 or 5 cameras up to 50. And I mentioned that as you add cameras, you're probably going to have to add NVRs. As you start to expand a large site, now is the time that you want to start to consider using centralized storage. You have 2 choices. You can go with NAS with limited bandwidth capability, or you can go with iSCSI, which is streamlined and has basically double the capability per box or per subsystem, if you will. So in this particular case, I've denoted a number of cameras. They're all high density. I like how they're almost in a heart shape. And the cameras are then assigned to each of the individual NVRs. When we have a purposed Falcon that only runs an operating system, no storage for video at all. So you would take X number of cameras, you would designate them to a specific NVR, and that NVR will present a disk drive for those video feeds to be written through. But it's virtual. It's not contained within the actual Falcon VME or the NVR. Instead, when it receives those feeds, it sends it back to a central receptacle. In this case, it's a single controller product. So you can now vary your load across multiple VMEs. You can expand as you need more horsepower. You can apply separate management engines into this network, but all of the data is transparently held in a central receptacle. So within this one blue box, you would be presenting, say, 2 drives through Falcon A, another 2 drives through Falcon B, and another 2 drives through Falcon or NVR number 3, or C. I should mix up my letters and numbers here. So what's key to understand is iSCSI storage appears to a server or an NVR as a directly attached drive, drive D, drive C, E, F, G. You can continue your drive level counts. We don't have a limit on how big that drive can be. You can start out and that drive can be 16 terabytes, and later on you find out that your cameras are putting out more data. You want to up the FPS. You want to change the quality of the compression algorithm that you're using. You can expand each of those drives transparently to your application. Going with centrally held storage, your servers are smaller, they cost less because they're physically smaller, they use less power, and they don't have as many disk drives on them. We reduce the footprint of your actual servers, and we use higher density drives in our centrally held iSCSI storage. Okay. Touched on NVRs and cameras can be added independently of storage, and storage can be expanded independently of NVRs or cameras. Okay. Our iSCSI storage can also be added vertically or horizontally. And I say vertically, you can take this one box and underneath it expand its total capacity within a single iSCSI product. It will always look like the same drives, D, E, F, and G. Or if you meet the maximum capacity of any one of our products, you can add a second iSCSI and its consequential vertical expansion into this network, and then direct camera traffic to that second iSCSI storage solution. Any questions,
I have
Silver?
a quick question that came in.
Sure.
About approximately, what is our storage capacity in one of these systems if we go vertically and horizontally?
Okay. On our iSCSI product, our single controller product, we can expand up to 84 drives on the 3U based product and 96 drives on the 4U based product. So in a single controller situation, we can go up to what's at 192 terabytes before you'd have to go and create another stack, if you will, of storage. In our high availability product, which is the Seahawk SX product, we can run that up to a petabyte without any problem. So, and that typical environment starts at 16 terabytes by virtue of the requirements that seem to come along with high availability and so forth. But that product is highly expandable, and that's within one, if you will, stack or subsystem, and then we can add on another one, and we can add on another one. Is that a good answer there, guys? And I think I'll be able to show that a little bit later. Any more questions?
No, we're good.
All right. Okay. I'm going to take a second just to familiarize you guys with our iSCSI products. Our families are broken into 2 basic groups. We have the single controller product, and we have our high availability product. Now, a single controller product, sometimes you say, well, it's not as good. Stop just a second and understand that all of our IP SAN, even our single control products, have redundant hot swap power supplies. They have hot swap disks. They're afforded RAID protection. Your choice, typically it's RAID 5 or 6. and they're highly expandable, as you can see below. The 3 U's to 160 terabytes and the 4 U's to 192. They also are very high performance in unto themselves, and they can even support multiple 10 gig ports. The single failing of this controller is there's only one iSCSI engine in it, and if you lose that engine, you will not be able to present video, you will not be able to record video. But let's face it, things are budget driven. And even within the Seahawk S family, we have a version called the L. The S is our fully featured product. It has included and embedded. It's part of the system. No external host, no external software. It can do local replication or backup. It can do, with an optional license, remote replication to a disaster recovery site that strictly holds the video. It doesn't have to be a fully blown failover site. But we recognize that there's a lot of cases where those features aren't required, so we have what we call the Seahawk L, or Lite. I spelt it like Miller Lite, I guess. And what we do is we just pull those replication features and those mirroring features out and save money, save the end user money on not buying something he doesn't need. Now, if at a later point he does want to back up his data locally, he does want to make an allowance for a remote site to hold the data, there's a license upgrade that you can apply to the Lite model. And it basically just brings you up to the cost of what the S model would have cost in the beginning. But keep in mind, our Seahawk S and L, I like that, products are highly available, they're very reliable, and they're very fast. But they are not high availability. What we're finding is the data requirements, the storage requirements, if you go back a couple of days ago, it was typically, 1 CIF, 4 CIF, I don't know, I only have to hold the data for a week to 15 days, and it was at 4 FPS. Today, almost all of our requests start at 30 days. Our FPS is generally 7 and up. Many sites are requiring 30 FPS. They're going to high-density cameras. And along with all of this storage is the realization that we can't do without. We need to be able to view it. It has to be recorded. I have to meet a 24/7 expectation with that storage. That's where the high availability Seahawk SX comes into play. The X stands for extra special. What we do is we take a very modular approach to our storage, all of our storage. In the single controller family, we can expand vertically. On the Seahawk SX, we break out the two iSCSI engines into two independent engines. There's no interconnect cross-back plane. They run independently, each of them with their own redundant power supplies. They both come with multiple NIC ports, one for performance, two for failover within the confines of those trunk ports, as well as the additional failover capability between the boxes. And then what we do is we have our array behind that, and that again is highly available. Not just hot swap disks, not just RAID, not just power supplies, but dual controllers. So when we talk high availability, I'll demonstrate. Okay, you can lose a NIC path in a Falcon or an NVR product, and it will auto path over through the second NIC. This is a feature of Linux and Windows referred to as MPIO, multipath I/O. Right? You can lose an entire switch in the process, and again continue to run. I can lose a controller in my array. Again, I'm still running. Not only am I running, I'm running, and I'm supplying video out to my monitor stations, and I'm receiving feeds. I can lose up to 2 disks in a RAID 6 configuration. Keep in mind, when we expand this product vertically, we're going to have multiple RAID 6 or RAID 5s within that architecture. So if you were in a say 64 terabyte configuration raw, you would have 2 RAID shelves, and you could lose up to 2 drives in each shelf, and you will continue to function. I can lose half of my power supplies in any one of the modules and continue to run. I can even lose an entire concentrator, and it will continue to run. So I can lose any one of these items I've shown, or I could lose all of them, and the Seahawk SX is going to continue to chug. We use a term called active controls with auto failover and auto fallback. When the subsystem's running with both, when it's running in full functionality, it's automatically load balancing video between the two. It's maximizing the amount of data that it can take into itself at any one time. If any of the components fail within a Seahawk SX, I lose a concentrator, I restore the concentrator, it will auto fail back to the configuration that it was running at optimally with everything running. That's the same thing for the array controllers, power supplies, just go back into a balanced situation. But I can lose controllers, I can lose disks, they will auto-rebuild the data back to themselves. So it's always a self-healing process when you restore the failing field a replaceable unit. Okay, so within the DNF security world, we have our single controller, we have our high availability, but we also add, and I'm going to touch on, and I talked about it a little bit earlier, mirroring. Okay, here's a very simple Voyager stack, and there's just a requirement for backup, and that could be locally or it can be remotely. We embedded standard in the standard products is the ability to mirror locally. Now that doesn't mean the machine has to be right next to the other machine. We can take that second product and connect it via glass up to 1,000 meters away. So if you had a concern about a specific floor being damaged or a building being damaged and losing all of your data, as highly available as it is, if that building burns down, I'm sorry, the Seahawk does not have any self-extinguishing capabilities. So depending on the importance, I realize budget comes into play, you can actually do a mirror, and it's built into the unit. It will talk and replicate bit for bit, byte for byte, from the Voyager on the left to a single controller product that can be up to 1,000 meters away. And sometimes that's still not enough. But let me backtrack. You don't have to mirror between like devices. Within this product that we're talking about, I can mirror between ISCs. I can mirror between a Voyager and an ISC. I can mirror the same data up to four different places if I want. So there's a lot of flexibility. Let's say that you have 2 Voyagers and you wanted redundancy between the 2. You can actually do a 2-way mirror between, I'm sorry, I said Voyager, between 2 Seahawk SXs, or you can do bidirectional mirroring between a single controller product and a high availability product. So you're not relegated to a single direction mirror. You can actually mirror back and forth, which is a particular advantage if you ever have to restore. What's starting to take hold now is in the security environment is what happens if I lose my central site? I lose all of my data, and I don't have any way to even figure out what happened. One of the funny things is we were working on a airport opportunity, and it was a fantastic system. We had monitoring all over the place. We had redundant self-failing over and falling back in VRs and everything else. And I posed the question, what happens if a terrorist blows this building up? How are you going to know what happened? And there was a big pause, and they said, I guess we need a disaster recovery state. How can we do that? This is how we do that. It's an optional asynchronous replication license. depending, it only moves net change across the pipe. So your first replication cycles of all of the volumes, and after that, it only moves net change, so your bandwidth requirements aren't as high for subsequent changes in data. So consider that when you're planning. If we have resellers out there, consider that as a question to ask. And for our end users that are watching that, ask yourself that question. Is that a requirement today, or it can be easily implemented down the road?
Dick, I have a question that came up.
Yeah.
When you're mirroring or replicating, does the NVR software have to manage any of that?
No. That's the beauty of this. The software is embedded into the operating system that we developed internally. It's called Stone Fusion. Those features are built in and require no external hosts. They don't require any software or servers or anything else to do it. It's strictly built in. It's easily set up and managed in our GUI. And I failed to say this, all of our products you manage across the web. You log in, there's certain security measures, there's CHAP, there's a lot of other things that are involved for security purposes, but you log in and you, in a nutshell, I'm oversimplifying a little bit, you say, this iSCSI volume or drive, I want you to replicate it to this vehicle and that volume over there. And then you say go. Now on a remote replication you have some options. You can freewheel, which is happening all the time, or you can schedule it for night when there's lower traffic and less bandwidth being used within the total environment. Any other questions?
That's all I've got for now.
All righty. Okay, let's recap. A network attached storage, okay, as a storage appliance, not as a camera feeding data over. It's got limited speed because of the extra software layer that's there and the added metadata that's required to tell the NAS appliance, where do I put this data and where did I come from, right? But at a level of cameras, a number of cameras, when they're feeding the data in, it's a relatively simple protocol to enact, and that's the standard that we're using today. There are some new iSCSI cameras coming out, kind of spendy, and you have a lot of the backside restrictions that you have with smart cameras. They're limited in total scope of what they can do. But NVRs are best suited as a first or only receiver of camera feeds. We go back to the single site where you didn't have more than a 40 camera requirement. That's the perfect fit. So that's what I mean by first or only. When you add a second NVR because you added another 50 cameras, and you add a third NVR because you put in a bunch of 360-degree 8 megapixel cameras, and the requirement is 30 FPS, right, you're going to have to scale NVRs. At this point, it makes more sense than rather than holding the data within each of the NVRs or Falcons in our world, it makes more sense to centralize the data. To take advantage of lowering your cost per gigabyte by centralizing it. Now your data is more easily managed. You don't go to this system to make changes there. You don't go to this system to make changes. If that volume needs to be bigger, you talk to the Stonefly iSCSI appliance and you expand it and you change it. NVRs follow the many to one or the many to few types of guidelines. So while you, as a positioning, much the same as we talked about with files and workstations and desktops, multiple desktops, many clients requiring access to a single point. It's the direct equivalent of many cameras requiring access to a single point. The Falcon, the NVR, perfect fit, all right? But when the name of the game is speed and bandwidth and expansion, now we switch over to iSCSI. You're going to have higher camera counts at different locations. They could be on the fringe. They could be across the country. They could be at multiple stations that are just within the same building. But when you need centralized storage, centralized management, higher bandwidth expectations, rather than a limit of 40 cameras with a single NVR, by virtue of the storage capability, the bump and processing, you can now facilitate 100 cameras through a single NVR. Centralized storage requirements, central storage for fringe installations, sites with multiple NVRs, and it reduces your overall storage requirements because you're now only going to buffer 1 or 2 days at the fringe. High availability requirements, hand in hand with iSCSI and its capabilities. You'll put in, as we demonstrated with the Seahawk SX, a virtually bulletproof product. Another one is, and I'll touch on this a little bit now, iSCSI storage facilitates the mixing of high-speed disks and lower-speed disks. There's a lot of camps out there with surveillance application software. Some take the data and they stream it extremely well and very efficiently, and they just take that H.264 packet, they run it through the NVR, put a tag on it, and they write it to the storage. All right, it's super. It's a highly efficient engine, and you get away with using SATA drives. But with features such as analytics or massaging of the data for retrieval purposes and so forth, the more sophisticated surveillance applications work in a database environment. And so they're making a lot more calls. They're not just taking the data and feeding it through. They're taking the data, they're parsing it, they're renaming it, they're manipulating it, they're putting tags on it, and that creates multiple files that are all accessing. Some of them are pointers, some of it's raw data, and this process is very I/O intense. So these types of applications require high-speed drives. And what we do is we work around that. We say, we understand your requirement for performance. How much space do you need for 1 day's worth of this work? And calculations say, I need 1.9 terabytes. We say, great. Why don't we give you 2 terabytes of high-performance data and on a daily basis archive back to less expensive 7,200 RPM drives. We call that 1 day storage. And it works out extremely well. So we're able to, in our subsystems, even within the same shelf, mix and match SATA drives and high-speed SAS drives without requiring a box for SAS and a box for SATA. And when you expand again, another box for SAS and another box for SATA. We can mix and match technologies within the same enclosure, which drives your cost down.
I think I have a couple of questions up
yeah.
If you can take a break on that.
Yeah.
The first question is, does iSCSI always need a fiber optic network? No,
it does not. iSCSI 1 gig is generally implemented with good old RJ45 up to that limit. If you're going over 100 meters, you would need to switch to short-range glass, short-wave glass. That brings you up to 1,000 meters, I believe. I got to check the numbers. It swings depending on certain things. And then if you need to go farther than that, you would go to long-range fiber optic. But up to 100 meters from an NVR to the storage. And then, in fact, you're going to go NVR 100 meters to a switch, and then from that switch, 100 meters to the actual iSCSI storage.
Okay, great. I've got another question here for you. What open source software is the Seahawk built on?
The Seahawk is not built on open source software. It is our own proprietary operating system. It was developed by a company that we acquired, 3 years ago. It's called Stone Fusion. Our engineering team's out of San Diego, but we own it, and it's, in my opinion, the best in the business.
Okay, and I've got one more. Looking for your opinion on centralized storage where all the fringe sites send data but no fringe storage. How does that work?
Okay, you have to be very careful when you're dealing with fringe requirements. I once, and I mentioned this in the thing, I subscribe to buffering at least a day's storage. But if you've got a big enough pipe running from the different fringe locations to a central location, you can just write that data straight through to a centralized vehicle. You have to be careful. So many of the fringe requirements seem to be old fringe requirements, and that's the way it was always done. And then you say, what's the pipe? And they go, I got a 10 megabit per second pipe. Not going to happen. If you want real-time writing back across an IP SAN, you have to have a 1 gig length from those remote sites. Now, that's a little bit different because, remember, you're taking data live and it's volatile. You can't back it up. You can't buffer it enough. The alternate to that is if you have enough pipe and your net change in the day, you can archive it daily, twice daily with a lot of packages, and do a buffer, and then archive across the slower pipe. That would use the application's archive capability.
Okay, great. Thank you.
Alrighty. Our particular product, we have the option with or without, but we have embedded local mirroring. We touched on that. So you can do backup without needing servers or software. It's a simple set it and forget it type of thing. We have optional embedded remote replication for disaster recovery provisioning. Again, no external servers, no extra software. And I didn't touch on this in the presentation because I was running out of time and I didn't want to add a screen. We have a feature, and this is one that's kind of catching on. It took a while. We can actually encrypt at a volume level, so the data that's sitting on the disks is encrypted. So if anyone was to come in and take the data, they would not be able to read the data. And on top of that, this volume level encryption at a primary site, if you replicate to a mirror or if you replicate to a remote site, the transmission of that data is encrypted. More and more, particularly government sites, are starting to make the actual data, it's called at-rest data, has to be encrypted to protect the facility or whatever it is from being able to have unauthorized viewing of this product or of this video. So we do have the optional ability, again, to encrypt the data that actually resides out on the iSCSI volumes. So keep that. That's a new question to ask, and we're seeing that in more and more RFPs. In fact, at least 20% of them now are starting to show that requirement. But that's it, basically, in a nutshell. A quick recap of NAS versus iSCSI. Simple thing, multiple NVRs, high bandwidth requirements, iSCSI. Limited fringe applications, limited camera count, single site, stick with the NVR. I'd like to open it up now. I see some blinking here. Go ahead and throw any questions you can our way, and we'll try our best to answer.
I do have one here. What NVR software do we support and or recommend?
We don't recommend anybody's. Hang on, let me mute here a second. We are application agnostic. We work with virtually everybody. We've tested with everybody. We're partners with a large number of different application companies. Milestone, ONSSI, Exact, Amatus, Genetec. But our posture is, and it's an expensive posture to take, is we want to supply storage and NVRs and infrastructure that will work across everybody's platform. And consequently, we have several people in our lab that all they do is evaluate software and make sure that it's compatible. We have very close ties with a number of the different applications support people and design people. So we're agnostic in that vein, and we intend to maintain that just because it makes sense.
I have one more question here. Why wouldn't we use smart cameras in all our installations?
Smart cameras are a great product, and I pick on Mobotics because I remember their name. But they're limited in scope. You know, it's one thing if you're recording, you know, with 16 cameras and your requirement in life is to be able to review them for an employee taking things out the back door, those types of things. But you have to offset this with the cost of the cameras. They generally cost more, and if you look at the licenses or the software packages that are available, after a couple of cameras or X number of cameras, if you went with an application-driven product sitting in an NVR, you get more features, you get more capabilities. And when you break through and you need analytics, or you want analytics at license plate the level, or you want the application to trigger on motion rather than the camera, so that they can filter out non-reasons to trigger, you're forced to go to an application-based environment rather than the smart cameras. I think the smart cameras are great, they're cute, but as you start to grow, generally speaking, there's going to be a point where you just say it costs less to switch over to an application mode rather than a smart camera.
Okay, well, thank you.
I appreciate it. Anything else popping up that you want to run by us?
I think we're clear for time. Any last questions, folks? Okay, I guess we're clear. Thank you.
All right, and again, just a quick reminder, when you pop out and you leave, if you could take a few seconds to let us know. We appreciate the feedback, and it's only going to help us make better presentations and give you the information that you want and need. So with that, I'll sign off. Thank you very much.